On to another type of transformation in 9.2. The I can statement for this section is I can understand and perform reflections. So let's go ahead and write the word reflections right there. A reflection is probably something that you've heard of before. You know about reflections in mirrors and things like that. And we're gonna use that idea as we describe what a reflection is. But first we're gonna do the warm-up question. So the warm-up question is, what do the following lines look like? Y equals x, y equals negative x, y equals 0, and x equals 0. So I'm going to draw a little xy plane on each one of these, and we're going to figure out what these look like. So I'm going to come back here in red. Remember, y equals x, that has a positive slope. It goes through the origin. Perfect 45 going up from left to right. Y equals negative x, it has a slope of -1, so it looks the same. It's just going down. We did these toward the end of yesterday's assignment. And then we've got y equals 0 and we've got x equals 0. Now remember, y equals 0 is horizontal, and x equals 0 is vertical. So y equals 0 actually means the y coordinate is 0, so it crosses at the origin, and x can be anything you want. So this line right here is the line y equals 0. It's a fancy way to describe the x-axis. X equals 0 is a vertical line that goes through x equals 0. Okay, so x equals 0 is right there. And then you can go as far up or as far down as you want. So x equals 0 is a fancy way to describe the y-axis. And quick reminder, a rigid transformation does not change the size or shape, but it can change. So remember, rigid, it's got to kind of be the same shape, but it can change the orientation. It can change the way it's pointed, is how we describe that. So I've got some of this next paragraph filled in, but let's remind us of what we're talking about in this particular unit. We're talking about transformation. So we're going to learn about another type of rigid transformation. So write the word transformation called a reflection. Now here's what a reflection does. It involves making a mirror image, gosh, maybe that's why they called the new ones the image, of the original figure across a line of symmetry. So here's how you spell symmetry, S-Y-M-M-E-T-R-Y, symmetry. So the line of symmetry, and we're going to draw this on most of our figures today, can be thought of as a line which we could fold the graph paper. So we could fold the graph paper along that line of symmetry, and the two figures would lie right on top of each other. And I'm going to show you an example of that right now. So let's take a look at example number 1. The instructions for all these seem to be the same. It says graph the image of the figure using the transformation given. Use proper notation for the image. In this box right here next to example A, it says be sure to draw and label the line of blank on the graph. Well, we're going to be talking about lines of symmetry a lot on this. So write down the word symmetry here. So we're going to be drawing the line of symmetry. Draw and label the line of symmetry on the graph. So on this one it says we're going to reflect across the across the y-axis. So let's draw the y-axis on here. So to do that, I'm going to draw a dotted line right here. Okay, so we're just going to do a dotted line right there. Okay, that is the y-axis. Okay, so there's our line of symmetry. So what we're going to do is imagine if we were to fold this graph paper along this line right here. So the left side would flip up here over on top of the right side, or the right side over on the left side. Okay, and we want to make a mirror image of that figure. So here's what we do. One way to do this is to take that line of symmetry and let's count how far we have to go and in which direction we need to go to get to, let's take I first. So we're going to take I. It is 2 units to the right of that line of symmetry, of the mirror line, if you want to think of it that way. So instead of going 2 units to the right, we're going to go 2 units to the left. So we'd have a mirror image right over here. So I'm going to put I prime right here. So what we've basically done is we've kind of made a mirror image over there. We're going to do the same thing with N. So going straight out from this line of symmetry, we go out 4 units. And then we're going to go over here 4 units. So 1, 2, 3, 4. So that would be right here. That would be N prime. So we're kind of taking this and doing a mirror image of it over there. And then same thing down here on F. We're going to go straight out from the line at a 90-degree angle, if you want to think of it that way. We're going to go over here to F. That's 2 units. So we're going to go over here 2 units to the left, and we're going to put F prime right there. So again, we're kind of doing a little mirror image going this direction right here. So this is the new image. This is the old one, and this is the new one. So this is the pre-image and this is the mirror image of that old pre-image there. So we've got our line of symmetry. So you can kind of see that right here, this is like a reflection of that one right there. Now over on this one it says reflect across the line y equals x. That's a little bit more complicated. So I'm going to go ahead and draw a dotted line right here. Okay, so we're going to draw along there. There is the line y equals x. That's the line of symmetry. Okay. Now what we're going to do is we're going to go straight across this line. So unlike over here where we had these nice grid lines to count across, what we're going to do is we're going to count diagonally. Now if this is a 45-degree angle going up, we're going to go this direction, a 45-degree going up here, because that would be a 90-degree angle right there. So we're going to go straight along this line and we're going to think, okay, that is one diagonal box away from the line. So let's come over here and let's go one diagonal box away from the line. We're going to put it right there. So that is going to be C prime. Let's do the same thing with x. That's one diagonal box, two diagonal box, and notice how these line up right here. That's kind of cool. So 1, 2, 3, 4. 4 diagonal boxes from the line, not from this point, but from the line. So we're going to go 1, 2, 3, 4. So we're right there, and that is x prime. And then we've got z over here. So this one gets kind of interesting. So notice right here, if we were to go at a 90-degree angle, notice how that's right here. And if we counted along on this diagonal box right here, so this is one diagonal box, two diagonal box, half a diagonal box right there. So there's a half a diagonal box, there's another full diagonal box, and there's another one. Okay, so this is going to be z prime right here. Now let me show you that again. Right here, it's one full diagonal box. So one full diagonal box below that line. 4 full diagonal boxes. So 4 full diagonal boxes going this direction over here to get to x prime. For this one, we start right here. There's a half, a full one, so we're 1.5, 2.5. So let's go the other way. There's a half, there's 1.5, there's 2.5, so we're right there. So let's go ahead and connect those. And you're going to hear this later on in the classes you take in high school. This particular type of transformation or this particular type of reflection is one that's used a whole bunch. So if you want to see that these truly are mirror images of each other, here's what I'd like you to do. Tilt your head to the right about 45 degrees. So if we tilt our head and we kind of line our head up like this, so tilt your head about 45 degrees, kind of like so this would be straight up and down. These two would lie right on top of each other if we folded those. So we've kind of made a reflection over here, a reflection over here, and a reflection over here. And again, I'll put some little arrows on that so we're kind of going across there. And what we're reflecting across is the line y equals x. So if you can tilt your head a 45-degree angle and you can see that those line up, those would be reflections across the line y equals x. You might wonder what it looks like if we reflect across the line y equals x, which direction, or sorry, y equals negative x, which direction we tilt our head. Okay, so keep that in mind there. Now, there are only 4 types of reflections that we're going to worry about. We could reflect across any line that we wanted to draw on here, but we're going to try and keep it as simple as we can. So the 4 main reflections that we use are across the line y equals x, across the line y equals negative x, across the x-axis, which would be y equals 0, and across the y-axis, which would be x equals 0. So the reason I had you draw these lines up here in the warm-up is because those are the 4 lines across which we're going to reflect lines. So I do want to take you up here and I want to take a look at this one right here on example 1, and I want to point something out. On this one, notice that this was the point 2, 4. And this point right here was the point -2, 4. So you'll notice that the y stayed the same, but the x changed. And then over on this one, we've got c is 0, 2, and c prime is 2, 0. So on this one, the x and y coordinates stayed the same. It was just the x coordinate that changed sign. So it went from a 2 to a -2, because all we did was instead of going to the right 2, we went to the left 2. On this one, something weird happens. It used to be 0, 2, but when we reflected across that line, it becomes 2, 0. So the x and y switched. So there are actually some very short mappings that we can use that will describe these, and I'm going to go through those on the next page. but I want to just use these mappings and see if we can figure out what's going on here. Now on example 2, all we need to do is just go through and use proper notation to follow this mapping right here. And I do want to point out one quick thing to you as we do this. So here's what we're going to do. The x stays exactly the same. We're just going to multiply it by a negative. So what I'm going to do is I'm going to draw an arrow and I'm going to put a -1 here. Okay, that arrow means we're going to multiply it by -1. In fact, let me put that in parentheses. That might make a little bit more sense. Okay, and the y is going to stay exactly the same. So I'm just going to put an arrow on there. So t prime is going to be negative times negative is a positive. And this is just going to stay exactly the same. So you'll notice that on this one, the x gets multiplied by a negative. So we take the old x, multiply it by -1 to get negative x, and the y stays exactly the same. So I'm going to use that notation here. I'm going to multiply by -1, stay the same. I'm going to multiply by -1, stay the same. Now this might seem silly on this one, but you'll see why this is really useful in just a second. So 3 times -1, -3. -1 stays the same. For e prime, 2 times -1, -2. The y stays the same, so that would be -5. So that right there is your answer on that one. Let's come over here and take a look. Now this one, notice what happens here. We've got a x and a y, and it changes to -y comma x. So the x and the y switched places and they changed signs. The x and the y switched places and they changed signs. So here's what I'm going to do. We're going to switch places with the two of these. So we're going to draw an arrow, and at the end we're going to put in parentheses what we're going to multiply them by. So we're going to multiply by a -1 here, and we're going to multiply by a -1 here. So j prime is going to be, we take the old y because it's going to be the new x. We're going to switch these. Okay. So we're going to multiply by -1 and we get a -3. We get 3 times -1, so that's going to be a -3. Now that doesn't change a whole lot, but take a look at this one right here. Again, we're going to switch the order of the x and the y, and we're going to multiply each one by a -1. So this is going to be a prime. This is going to be -4 times -1. That would be 4, so we get a +4 on that one. And then we get 7 times -1, so that would be -7 there. So notice what happens here. We used to have 7 -4. Now it switched to 4 -7. So they switched orders and they changed signs. Okay. Then on this one we're going to do the same thing. So put an arrow, and then we're going to multiply by -1 when we get done with each of those. So m prime is going to be, this is going to be a -2 when we multiply here, comma, and this is going to be a -5 when we multiply here. So again, we used to have 5, 2. But now this mapping says that we change places, we switch the x and y, and we change the signs. We multiply them by a negative. And there's the answer to that one right there. Okay? All right. That's how we do it with points. Let's go ahead and take this and figure out what goes on here and see if we can describe what this transformation is. So again, it says graph the image of the figure, use proper notation. So here's what we're going to do. We're going to take the x and the y and we're going to switch them. All we're going to do is just switch them. Okay, so let's take a look at this right here. Let's take the point L. Now point L is, let's see, that's over 4 and up 3. Over 4 and up 3. Let's take Z. Z is, let's see, over 4, and we don't go up or down. And Y is 0, 0. Okay? Now, here's how we make these new points. Now, I'm going to do this one kind of the long way here. I'm going to make each one of these into their new points, and then I'm going to graph those, and we'll see if we can come up with a description, because they haven't described to us what the line of symmetry is, how this is reflected, or anything like that. So let's see what happens here. All that happens is these switch. So the x becomes the second coordinate and the y becomes the first coordinate. So all we have to do here is just switch these. So this is going to be 3, 4. All we have to do here is just switch those. So that becomes 0, 4. And all we have to do here is switch those. So that actually stays exactly where it was. Now, up above, we actually drew the line of symmetry here, and we drew the line of symmetry here. You can't do that on this until we're done graphing this. So let's see, where did L prime end up? L prime ended up at 3, 4. So we're going to go over 3, and we're going to go up 4. So that would put it right here. So there's L prime. Okay, let's take a look at Z prime. Z prime is now at 0, 4. So we don't go right or left, we go up 4. So that would put us right here. So Z prime is right there. And y prime is exactly the same as y was, so it's right here. So there's y prime. So I'm going to go ahead and connect those. And then can we draw a line on here, or could we figure out where would we fold this graph paper so that those two could line up with each other? Now I did this one on this page for a reason. If you take a look right here, remember if you tilt your head and these two look like mirror images of each other, tilt your head 45 degrees. So tilt your head so it matches up with this line right here. That is the line y equals x. And if you tilt your head, look, this is a half box over here, that's a half box over here. Let's take a look at z. One full box, two full boxes, one full box, two full boxes that way. And this one's right on the line of symmetry, and that's why it doesn't move at all. So this is a reflect, or I'll say reflection across y equals x, that perfect 45 going up in the upward direction. Okay, now I'm going to change colors here for this one. You'll notice that on this one right here what it does is, and I'm going to blow this one up so we've got a little bit of room here. Okay, so let me slide this down. It takes xy, x stays exactly the same, and then y becomes the opposite of what it used to be. So I'm going to write down y is, this would be 0, 1. W is, let's see, back 2 and down 4, so -2, -4. And U is, let's see, back 5 and down 1, so -5, -1. Now here's what we need to do on each one of these to make them the new points, y prime, W prime, and U prime. We're going to take the x and keep it exactly the same. Okay, so the x stays exactly the same. So I'm going to make this a 0, I'm going to make that a -2, and I'm going to make that a -5. What happens to the y? Well, whatever y used to be, we multiply it by a negative. So we're going to multiply it by -1. So if we multiply that by -1, -1. Multiply that by -1, we get a 4, and multiply that by -1, we get a 1. So let's graph these. So let's go ahead and graph y prime. Y prime is 0, -1. So 0, -1. So we're down here. So this is going to be y prime. W prime is -2, 4. So that means from the origin we're going to go back 2 and we're going to go up 4. So that would put us right here. So there's W prime. And then U prime would be -5, 1. So back 5 and up 1. So this would be U prime. So let's draw that right there. And this gets a little bit tricky. Is there a line where we could fold this so that the points lie right on top of each other? The new point lies on top of the old point, the new point lies on top of the old point, the new point lies on top of the old point. Well, there is definitely a line, and you can kind of keep in mind what we did earlier to figure out what the line is. So notice that these are right in line with each other, and they are perpendicular with a horizontal line. So if we're going straight vertical to change these, then the line of symmetry must be horizontal, and we'd want to pick something right in between. So what's right in between y and y prime? That point right there is. What's right in between y prime and, sorry, W prime and W? This is 4 right here, and that's 4 right there, so that point right there would be, and what's right in between the two of these? So here is our line of symmetry, okay? That would be the x-axis. That's our line of symmetry right there. So I'm going to shrink this down, and for our description we're going to say reflection across x-axis. Now notice what happened here. The x coordinate stayed the same, but it was the y coordinate that became negative. So we're going to put these rules together, these little function mappings together, and we're going to figure out how we could write this down. Now we've done a couple of these reflections across the line y equals x, and let's see what happened here. What happened is the x and the y just switched. That's it. So I'm going to go ahead and write down that the x and y switch. So this would be from xy, and we do yx. So we're literally just going to switch the two of those. Okay, this one right here that was a reflection across the x-axis, let's see what happens here. The x stays exactly the same, and it's the y coordinate that changes sign. So across the x-axis, it's the x that stays the same and the y that becomes the opposite of what it used to be. And I think we did one of these up above, but if not, the x changes coordinates and the y stays the same. And then this last one here, if it reflects across the line y equals x, this would be not be something that you would typically figure out, but we did do one of these earlier. The x and the y switch, so this is y and this is x, and they become the opposite sign of what they used to be. So I know that's a whole bunch of stuff to memorize and figure out. Luckily, we don't have to figure it all out from scratch. We've kind of explored this just a little bit. And now we're going to go down here and we're going to practice just a tad. So notice the figures. This will be a little bit quicker. They're already graphed for us. I'm going to definitely mark this one as the old one and this one as the new one. Might not be a bad idea to do that here. This is the old one and this is the new one. If we want to figure out what's going on here, you can draw kind of lines straight between these guys right here. And the line of symmetry would have to be perpendicular and have to meet that at a right angle. So that's got to be this guy right here. That's got to be the y-axis. So we're going to write reflection across y-axis. And remember what's going to happen with that, with a reflection across the y-axis, the x is going to change coordinates. So this is going to be negative x, comma y. The y stays the same. So take a look at this one right here. 2 comma 1. What we're going to do is we're going to take the x coordinate and we're going to multiply it by a negative. So that would be negative 2, and we leave the y coordinate the same. So is that point negative 2 comma 1? It is. Okay. And again, just to mention this here, always pay attention to which figure is the pre-image and which one is the image. The order is not as big a deal as on a reflection because the direction isn't so much as finding the line of symmetry here. So let's take a look at this one on example B. And again, with some practice, you'll be good at seeing these lines of symmetry. If you have any trouble with this, let's draw a dotted line connecting the new and the old point. So if we go like that, the line of symmetry has to be perpendicular to that and has to go through all three of those right through the middle. So here's our line of symmetry. Right there is our line of symmetry. There's that line y equals x that we should be able to recognize now. So this is a reflection across y equals x, and the rule for that, notice up here what happens, all that happens is the x's and y's switch places. So this is going to be, instead of xy, this is going to be yx. So we take the old coordinates and we just switch them. We switch places with them. So this one is 4 comma 2. So that means this one over here should be 2 comma 4. So let's take a look at that. Over 2 and up 4, we're right there. Okay, so those are reflections across the line y equals x. All right, this is great practice for stuff that comes later on. I realize that there's a lot to keep track of here with these rules. You can definitely use this on the assignment if you need to describe what the mapping is or something like that. I do just want to point out, if you look at the old one and the new one, the image, or sorry, the pre-image and the image, do you notice anything about their orientation, the size, the shape, and things like that? Well, the size and the shape are exactly the same. Okay, so these two are the same. These are still congruent figures. The orientation, that part is different. They're going to be pointed a different direction once we reflect those. So that's the case here. So the M is pointed to the left, the M prime is pointed to the right. Here's the O pointed kind of down and to the right, up and to the left on the O prime, and the same thing will be true on every single one of these. This is kind of pointed off in that direction. This is kind of pointed a little higher, if you want to think of it that way. The Y is pointed up here, Y prime pointed down there. So they are congruent figures. They are just oriented in a different direction. All right, good luck on the assignment.